Hey, good morning, good afternoon, good evening, good early morning. You have reached Saturday Science Chats. Yes, you've reached Saturday Science Chats. Welcome, everybody. It's going to be a great day. We have a great show for you today. One of my favorite people of all time to talk with recently. I met him only a few years ago. I've known some people for many decades. We're going to be speaking with George Coyne coming up. But before that, want to just say to everybody, thank you for tuning in. This is sponsored by the John Chappell Natural Philosophy Society and the Dissident Science channel. And today we're going to continue our series on evolving perspectives on the history of science, talking specifically about the Big Bang. And today's lecture and talk and discussion will be about the universe is not expanding. I think there's some new data out there confirming this, but I'm not giving a talk. George is. He's super fascinating, never boring to listen to. I can listen to this guy for on and on. This guy is really a lot of fun, and also discussions. I always enjoy his discussions. But I do want to congratulate you for tuning in because you are a critical thinker. And somebody told me that Aristotle wasn't the one who said this. I don't know. I have been told that he did, but maybe he didn't. But it is still a good saying here that it is a mark of the educated mind to be able to entertain a thought without accepting it. What does that mean? Hey, if somebody has a new idea, give it a chance. Take a look at it. Don't judge it just because it goes against something you may believe to be true. So that's always the case. And I do want to thank everybody again for watching. And please hit the like button and subscribe button. So if you're watching right now, just take a second, go up there and click on the like button. If you have wandered in and this looks like it's interesting to you, well, subscribe. That is, click on the little subscribe button there. If you're on YouTube, that has a little bell there, and then you can say all. And if you click on that, you'll be alerted to when we go live. So that really helps. So we do appreciate it. And again, thank you so much for being a critical thinker and tuning in with us. Of course, the Chappell Natural Philosophy Society's mission is to promote critical thinking without malice. That means you should be able to talk about ideas that go against mainstream ideas. We can do that, folks. It's not a question of whether it's right. We have free thought, at least for what we say is free thought. Yes, it's all deterministic depending on who you're talking to, for sure. But I mean, we are free to, in our own minds, think about what we want, and we can throw something out or find problems with something and try to come up with new ideas. And that's what this organization is about, because as I talked about last week, the majority is always wrong. That is, it's the minority 3% people who are outside mainstream that push us to the next level. The majority is simply the consensus of today, and waiting for somebody in the minority to give us a whole different type of picture. So we do support that. We support topics in physics and cosmology, philosophy, mathematics, and other, and we do provide a forum for serious papers and theories, and online forums without fear of censorship. That is, if you come in and say, even if you say relativity is great, we allow that. We do have some people in our organization, not many these days, but who do think that relativity is okay, and we allow all those points of view. And of course, we are run in its entirety by our members. And if you don't know about us, this is your first time tuning in, the best website you can go to is beyondmainstream.org, and that's an online magazine for critical thinkers. You can go in there and say, what do you mean there's problems? Well, you can just go to that website and click on the category of problems, and you're going to see all the problems in particle physics and relativity and the Big Bang, in plate tectonics, etc., quantum mechanics. So take a look at that, and there's a lot of great articles there. And if you want to contribute, you can. Just let me know. Send me an email, and we have people writing articles for that. But we're coming up to almost 100,000 views on the pages there, so that's pretty good. And we also have a critical thinking community at naturalphilosophy.org. Yes, we are the keepers of naturalphilosophy.org. Of course, natural philosophy is what we called physics before we called it physics. It really is a study of the sort of the natural laws or the natural goings on of the universe. I know laws don't exist; we make them up, but at least looking at the natural, looking at the philosophy of how the universe works. So naturalphilosophy.org, you can go there and register, and you can become. Oops, look at that pop-ups on my computer. You can become a registered member and join in right away. We've got a lot of great discussions going on, a lot of stuff. I'm in there bantering around too because I'm right and everybody else is wrong. I'm kidding, but it's great stuff. Lately, it's been a lot of hot topics there. Great discussions going on. I want to congratulate everybody who's participating. And of course, we do have a Wikipedia, a Natural Philosophy Wikipedia, which is you can go to by going to wiki.naturalphilosophy.org. And we have over 10,000 pages of people's work and abstracts and those kinds of things there. So take a look at that. And also, we do live off our memberships and donations. So please, please, please think about becoming a member. You can do it monthly, like $5 a month. Come on, what's that, $60 a year? It's important. We have $2,300 a year just on our expenses because of the online presence for the server, for a server not to get hacked because we get hacked because we have controversial things, meaning people don't like it when we say the Big Bang's wrong. So we have to have that. We have software that we run, that we buy, that makes us have a really great site. That's now, we don't buy, it's subscription now. Everything's subscription. So with the server, everything backing up the whole system, because again, we were hacked in the past. We haven't been, thankfully, because we pay $300 a year to make sure people can't come in and hack us. And all of those things add up. And I'm not a independently wealthy person. I wouldn't have a problem. $2,300, that'd be nothing. But nope, I work a lot like everybody else, or a lot of people are retired. But if you can afford $5 a month, if you can afford more, that's great. You can do it annually, 35, it's even less. But I do want to thank our patrons. Some people have been making donations regularly, and it's really greatly appreciated. Nick Percival, Dr. Cynthia Whitney, our chief scientist, and Ramsey is pen name. He has helped out, and of course all of our annual and monthly memberships. I do notice some people joining, so come on, support us here. This is the only channel, this is the only organization on the planet that's going to let you do this. Electric Universe does allow some of this as well, and I know a lot of people have presented there, so applaud to them too. But we are a little bit more general than they are. They concentrate more on the universe, the electric aspect of the universe. So I want to just say again, we need your vital support, because as our donors come and go, we don't want to get to the point where you said, where is everything, because we can't pay our bills. So a little bit from a lot of people certainly helps. So coming soon, Nick Percival, he is preparing, I think he's got one already done, is working on a second one, The History of Special Relativity, our evolving perspectives on the history of science series will continue. We have some other ones coming up, but that will be coming up soon. The history of science, the history of special relativity. So Nick is one of the foremost experts in relativity, in my opinion. And if you haven't checked out his channel, he's got a channel called Nick of Time. Look that up, Nick of Time and Relativity. Put that in YouTube and you will find it. He's got a bunch of videos there, really, really worth watching. He's got an excellent mind, very, very, very bright guy, of course. And so we look forward to his talks on the history of special relativity. We have it, it's already set at 1 p.m. Eastern on March 5th. Normally we are at 10 a.m. on March 5th. But this person, Tallman, who is a pretty noted and modern, he writes books. He's an author. He's been reviewed by New York Magazine, the London, he's look him up. He is one of the up and coming new writers in a new genre called, I think, auto. I can't remember what it's called, but it's sort of like autobiography, but it's autofiction, I think it's called. And he wrote a paper and has been actually talking with our guest today, George Coyne. And I noticed, actually, I got a paper, a link. I've got an email from him saying that he wrote a paper about science and things, in the critical thinking area. And I was quite surprised. I had no idea who he was, but I looked at the article and I said, "Hey, Tal, would you like to talk about it?" He was sort of hesitant because he's an author, he's a writer, but we have finally set up a time, and he's going to be discussing alternative models and other topics in physics and cosmology. Also about his book, I do have his book here, Tao Lin Leaves Society. It's got great reviews. Very, again, just outside the box when it comes to writing as well. So we're going to be having that session, but we're starting right now. Just go 3 hours ahead wherever you are in the world. I am sending out now. Thank goodness I am sending out links so you can find out when we're actually happening in your part of the world. You just click on that link and it's going to say, oh, it's happening at this point. That one's going to happen a little earlier. And then we also have coming up probably one or at least two talks by Bob de Hilster on the physicality of parallel. The next one will be physicality of parallel resistors, diodes, and transistors. It's very interesting to see a physical model for these things, given we have lots of empirical electrical engineering equations that have to do with nothing real in physics. And my dad has been working on that. And actually, we're going to start writing papers to submit to real conferences, not just maybe IEEE for electrical engineering. My dad came up with a hack for the ultraviolet light that can't be explained. Planck's constants used and arbitrarily puts in integers to explain the ultraviolet light problem, which is called catastrophe. This week he came up with it. If you haven't seen his video, take a look at it. Go to the Particle Guru and take a look at his latest video. He talks about how our model actually can describe the unresolved the ultraviolet catastrophe. So we're looking to write a paper about that and try to submit it to some real conferences outside, mainstream stuff. So really great work going on. And he's a young 84, so that'll be good too. Now we're going to get to George Coyne. George Coyne is a Canadian philosopher, science writer, educator, and counselor. In his book, Notfinity Process, Matter in Motion. Oh boy, I got that wrong. It's not microcosms in motion. What the heck there? Okay, I've got to edit this. Whoops. Sorry, I'm going to edit come on. There we go. I should be able to edit this. Escape. There we go. And I'm going to do this right by him. There we go. Matter in motion. He's going to kill me if I don't do that. I always have to do at least one slide. So there you go. Oh, there it's right. Let's try again. George Coyne is Canadian, and in his book, The Notfinity Process, Matter in Motion, he critiques relativity theory, the Copenhagen interpretation of quantum mechanics, and Big Bang cosmology, which he'll be talking today, while promoting credible alternative models that do not contain paradoxes or contradictions. He writes about a new paradigm for consciousness, which does not require anything other than a brain functioning. That's absolutely stunning stuff. If you haven't seen his presentation for that we did 7 months ago, take a look at it. You can either go to the CMPS channel, or if you're from Dissident Science, you can go to Dissident Science. Just search for Dissident Science George Coyne, or you can go to CMPS George Coyne. Look that up. Really amazing talk. I really love it. I got his book, and the other thing I really like about that, and I'll get to his book now, is Notfinity Process, Matter in Motion. See, I got it right there. I just had that from an older slide and his bio, and I had it wrong. So you can see Matter in Motion. Nice cover, by the way. I wonder who designed. I'm kidding. Anyways, something really interesting that it took me a while to really, how do you say? It's not. I can hear it, but you really feel it and understand it. Is the word Notfinity. you have the word infinity, and one of the problems with infinity is if you have like an infinite amount of hotels and one person goes into them. Each hotel has 20 people, and one person is standing in front of that hotel. You've got a 1 to 20 ratio between you, one person, and the 20 rooms, and now you make an infinite number of them. Well, that one infinity is bigger than the other infinity, and you start to get into this like, oh my gosh, this mathematical conundrum where you can get stuck in the hall of mirrors. And I think what I like about Notfinity, it's like, no, it's not. It's it's not. You don't have the problem with the infinity. So that's. I mean, in the sense of the term. So that's pretty interesting. Of course, matter and motion comes from Dr. Glenn Borchert, one of the great scientists of all time. My dad and I's model is also based on that. So. I think that's it. Do I have anything else there? Oh, no. So today he'll be talking about, this is the last slide, I think. Again, this is a series of evolving perspectives on the history of science. We're going to be talking about the Big Bang. George can be talking about the Big Bang today. We'll have a discussion as well. So after after his talk, we stick around. We're going to you can ask him questions if you want to join. Oh, if you do want to join us live, you can. How do you do that? It's pretty easy. You just go to live.naturalphilosophy.org. Every week I change that to our new address because each one of these presentations has a new address, but you don't have to remember that address ever. Just go to your browser, type in live.naturalphilosophy.org, and you're going to say, what software do I have to use? No, it's all done in the browser. Browsers today have video conferencing built into them. So if you want to join us, we have 10 places in our what we call green room. I can bring you up and you can battle with George and go at it. I'll be the referee. If there's any fighting, really bad fighting, I can get in the middle of it. I'm just kidding, of course. But you can join. So think about that while you're listening to him, if you want to actually come on board and talk directly. If not, of course, we have our chat room. We've got our 3 channels going simultaneously. We're going live to YouTube. On the CMPS channel, we're going live to the Dissident Science channel, and we're also going live to Facebook, the CNPS on Facebook. So we are all of that. So with no further ado, I'd like to bring up our special guest and presenter today, George Coyne. How are you, George?
I'm great. It's great to see you again, David.
Yeah, I mean, you got up early. I mean, you and I are plant-based, and you and I have the same problem. Once I went plant-based and reversed my heart disease and my arthritis, and I reversed my allergies, and now, my family has heart disease. I don't have it. So the good thing, though, is, heck, I'm only sleeping 4, 5, 6 hours a night, and it doesn't seem to bother me.
No, I got up at 4:30, went to bed at 12:30, up 4:30 a.m. Vancouver time. I never sleep more
Yeah, it's amazing. It's amazing. So, and you're almost 70. Look at this guy. I mean, come on. No, I think he's lying. It's just,
October 2nd, 1952.
He's really 28. He eats fried foods all day, and he smokes. He smokes like a fiend. So...
No, my energy always stays up from morning till night. It never varies.
Yeah. So, but anyways, we met actually, I think at 2018?
At Duncan Shaw's in July 2017 at Duncan Shaw's home for the CMPS conference.
That's right, the CMPS conference, which we had at the University of Vancouver, which was probably maybe my favorite place to be because it was so darn beautiful there.
Yeah, you mean UBC?
Yeah, exactly. At the University of British Columbia, is that what it is?
Yeah.
Just beautiful, beautiful facilities. It was just absolutely great. I think we even had Dr. Gerald Pollack speak because he was around that area too. And that was at the Washington. We actually went to Washington, which was really close.
That was the next year, yeah.
Yeah, but it was really great. And then Duncan came up and he says, "Look, there's this kind of, he's a kind of eccentric guy, but you should really talk to him. He's really got some great ideas." Now, I've heard that before, and it's been sometimes a big regret. And I go, well, maybe he could even talk. And I'm thinking, oh boy, here we go. What is it? He's going to tell us that licking frogs is going to change the aurora borealis or something like that. But it turns out that I did meet you. When did we first talk? Was it at his house?
At Duncan, you didn't say who Duncan is. I think people
Oh
don't know.
yeah. I'm sorry, Duncan Shaw. I will. Yeah, Duncan Shaw is I call him now because he's retired. So what he did before it doesn't
Yeah.
matter. He is an etherist, the person who is trying to come up with an ether model. I call it the Vancouver ether model, where ether flows into like the Earth and flows back out. But he is actually I think he's a retired Supreme Court justice from in Canada.
For
And
BC Supreme Court.
right, BC, yeah, Supreme Court in British Columbia, and he was, we've known I've known him for numbers of years, and he's given presentations. Very astute guy, but he had said, "Hey, you got to talk to this George guy." So I did, and here we are today. And he's actually, I think I let you talk at the conference.
51 minutes, and it's had over 3,100 to 3,200 views already.
Oh my goodness, that was a
On
mistake.
consciousness.
And now I have to have you back because people actually want to listen to you. I don't know what it is, but I think the thing you gave the first talk was on consciousness, and it was
Yeah,
just
brain, mind, self, and consciousness. I can't believe the response, very positive response.
yes, it was. And I'm a computer scientist myself. I work in the area of getting computers to understand language, and so I've always thought to myself, what is consciousness? What if I replace my body, it's a little
Yeah.
piece at a time, will I be the same person? All that kind of stuff. So when you talk, I go, wow. This guy isn't crazy at all. In fact, I actually agreed with almost everything you said.
Yeah.
So I really want to thank Duncan Shaw for hooking us up. He's a great
Computer
guy.
scientists seem to understand my presentation better than anyone else.
Yeah, yeah,
They seem to get it right away, whereas other people who trained in psychology maybe are having trouble seeing that, consciousness is just another word for brain functioning, basically. And the brain doesn't produce consciousness. It's the same. It's just another word.
Right. Yeah. There's a lot of people who believe, there's something, that's more there, the soul kind of thing.
Yeah,
But
yeah.
for people looking at least the physical side of it,
Right.
I think, that's the most important thing.
Right.
And here's the upshot, folks, from consciousness and George Coyne. Don't worry about anything in life because it doesn't matter. You're not choosing anything anyways. It's happening. Just like Borkert says, because all the the microcosms and the macrocosms. So it's going to happen. So just don't
That's right.
fight it.
Absolutely. That's right. It saves energy.
So anyways, I'm going to let you talk, but it's a real pleasure. Obviously, I'm really looking forward to this. And again, I'll put some things on the bottom so people can.
And there's a friend of mine, Tallman, that you showed.
Oh, yeah.
He's going to be on the show. He sent me this book, and he drew a little picture for me too, if you want to see it.
Oh, do yeah. Let me see. Oh, yeah, that's cool.
And he mentioned in his book, on the note, he says, turn to page 151 or something, where he talks about the Big Bang in here.
Right.
Page 2, he says, check out page 250, 251. But he's a great guy. I like him.
No, he is. We're looking forward to talking to him. He's in Hawaii, unfortunately. So right now it's like, 3 hours ahead of time. So it's like 5 in the morning or 6 in the morning.
Right.
Anyways, we are going to be talking with him on March 5th. And it'll be at 1 p.m., which means for you guys on the West Coast, it
10
will
a.m.
be at 10 a.m. So you guys can sleep in or watch Saturday morning cartoons like we did when we were kids. So anyways, I'm going to let you speak.
Okay.
Welcome and thank you so much. I'm really looking forward, especially the universe is not expanding. I guess we have some new data on that, but I'm going to let the floor is yours.
And this will take like about 55 minutes, but
Okay.
and then we'll do questions and other. Okay. So I'd like to greet Glenn Borkart, Duncan Shaw, and Tallman will be watching later. I know the other two are watching live. And by the way, David, you did a great job of describing what the word notfinity means. That's fantastic.
Yeah, well, it took me a while to figure that out. It
I
really
know.
did. And you know what? Glenn, if you were actually watching live here, hey, I didn't think infinity could have been outdone, but not outdone, but at least added to. I'm sorry, George, you added something to it, but of course.
Well, the problem with infinity is it's become a concept, and therefore it doesn't represent what it's supposed to represent because it's become too much of a hardened concept. Anyways, I'll begin now. Okay. So the title of this presentation is "The Universe is Not Expanding," and it was derived from the chapter on falsifying the Big Bang Theory in Notfinity Process, Matter in Motion, second edition, 2021. And it basically is representing 15% of the material in that chapter. So if you are interested in this talk, I encourage you to get the book, because it goes into much greater detail and 66 different falsifications of the Big Bang. And it's also on sale right now, 1/3 off in paperback, and it's $26 US, 47 Canadian. Okay, so I'll begin with the definition of the Big Bang and inflation. Because some people may not be familiar with the basic components of the BBT, that's short for Big Bang Theory. So it's useful to provide the standard description as found in Wikipedia. And so here's their definition, quote, "The Big Bang Theory is a cosmological model of the observable universe from the earliest known periods through its subsequent large-scale evolution. The model describes how the universe expanded from a very high density and high temperature state and offers a comprehensive explanation for a broad range of phenomena, including the abundance of light elements and the cosmic microwave background," that's known as CMB, by the way, "radiation and large-scale structures. If the known laws of physics are extrapolated to the highest density regime, the result is a singularity which is typically associated with the Big Bang. After its initial expansion, the universe cooled sufficiently to allow the formation of subatomic particles and later simple atoms. Giant clouds of these primordial elements later coalesced through gravity in halos of dark matter, eventually forming the stars and galaxies, the descendants of which are visible today." End of quote. And I just mentioned that it took apparently hundreds of thousands, 200,000 years for matter to actually form, according to the Big Bang Theory, from that, from the energy or so. Okay, now, according to the Big Bang model, the theory of cosmological inflation involved an exponential expansion of space in the early universe. It lasted from 10 to the negative 36 seconds. That's 10 followed by 36 zeros of a second, negative. Very tiny. A trillionth of a trillionth of a trillionth of a second. That's how long it lasted after the hypothesized Big Bang singularity, to between 10 to the negative 33 and 10 to the negative 32 seconds after the singularity. Following the inflationary period, the universe kept expanding at a reduced rate. The acceleration of expansion caused by a supposed dark energy started after the universe was more than 7.7 billion years old. Inflation theory was developed in the late 1970s by Alan Guth, Alexei Starobinsky, and Andrei Lind as an essential ad hoc to the Big Bang Theory. And for people that don't know what ad hocs are, that's when a theory has problems, so you add on to it. And that's what inflation theory was. They had to add on to it, to the Big Bang. It continued to be developed into the early 1980s. It seeks to account for the universe's large-scale structure using the concept of quantum fluctuations in the microscopic inflationary region, which supposedly increased to cosmic size to act as seeds for the growth of structure in the universe. So now to get to the main part here, the universe is not expanding. According to Eric Lerner's team of astrophysicists at Lawrenceville Plasma Physics, the universe is not expanding at all. And anybody that is aware of Eric Lerner knows that he wrote the famous book called The Big Bang Never Happened. Now, in 2014, scientists tested the Big Bang Theory's prediction that ordinary geometry does not work at great distances. On Earth, the solar system, and Milky Way, as similar objects get farther from us, they appear fainter and smaller, while their brightness per unit area, i.e. surface brightness, remains constant. In contrast, the Big Bang Theory asserts that objects should appear fainter but bigger in the expanding universe as surface brightness decreases with their distance, and their light is stretched as the universe expanded, dimming the light further. Thus, the surface brightness of the most distant galaxies should be hundreds of times dimmer than similar nearby galaxies, so that they would be undetectable with present-day telescopes, with the possible exception of the James Hubble Space Telescope, which will not be sending back any images until June of this year, of 2022. When distance to a galaxy is more than several million light years, methods of measuring distance apart from the Hubble law are extremely problematic. And the Hubble law states that galaxies are moving away from Earth at speeds proportional to their distance, such that those at the greatest distance are moving the fastest from us. At large redshifts, the redshift distance relationship, the large-scale extension of the Hubble law, is used so that redshift is a proxy for distance. Although the Hubble law applies as a method of determining distance, the mechanism for generating the redshifts is as yet unknown. It may provide a measure of cosmic distance to the source observed galaxies, but it may not be the result of expansion. And that's what the point is I'm going to be making in this talk. But contrary to predictions of the BBT, that's short for Big Bang Theory, when scientists compared the brightness and size of about 1,000 nearby and extremely distant galaxies, using the most luminous spiral galaxies while matching average luminosity of far and near samples, they discovered identical surface brightnesses of distant and nearby galaxies. And that should not happen. These results contradict the BBT prediction of a huge reduction of surface brightness, but agree with what would be expected from ordinary geometry in a non-expanding universe. Lerner stated, quote, "Of course, you can hypothesize that galaxies were much smaller and thus had hundreds of times greater intrinsic surface brightness in the past, and that just by coincidence, the Big Bang dimming exactly cancels the greater brightness at all distances to produce the illusion of a constant brightness, but that would be a very big coincidence," end of quote. To apply the test for surface brightness to match near and far galaxies, the researchers needed to determine the actual luminosity of the galaxies. So they used their redshift to link the distance to the galaxies, as is known to be true in the nearby universe. Using data on supernova brightness that is used to measure the universe's accelerated hypothesized expansion, the researchers assumed that distance is proportional to redshift at all distances. Study co-author Dr. Renato Falomo stated, "It is amazing that the predictions of this simple formula are as good as the predictions of the expanding universe theory, which include complex corrections for hypothetical dark matter and dark energy." Another co-author, Dr. Ricardo Scarpa, stated, quote, "Again, you could take this to be merely coincidental, but it would be a second big coincidence," end of quote. Thus, if the universe is not expanding, there must be another cause for the redshift of light that occurs with increasing distance. Something must happen to the light as it moves through space. Lerner remarked, "We are not speculating now as to what could cause the redshift of light. However, such a redshift is not associated with expansion, could be observed with suitable spacecraft within our solar system in the future." Am I still here?
Oh. Well, it depends on your philosophy, but I think you are.
Oh, okay. I just want to make sure that everyone's still hearing you, because it's quiet from that end. Okay, I'll continue. Expansion of space does not explain many phenomena. BBT does not explain the actual mechanism causing many redshift observations. It attempts to account for cosmological redshift by the expansion of space between galactic structures, but this fails to explain the following phenomena. 1, CMB radiation uniformity, that's cosmic microwave background radiation uniformity, and something called the fingers of God effect of elongated galaxy distribution in redshift space with elongation axis toward the observer. It is supposedly caused by a Doppler shift associated with the random peculiar velocities of galaxies bound in structures such as structures such as clusters. 3. A single redshift galaxy in compact galactic groups. 4. Solar limb redshift. Although redshift at the limb of the sun's disk could partially be accounted for by a plasma redshift mechanism. However, there could be many alternative explanations. It is a difficult matter to explain in every detail, such as why the relationship between limb position and redshift differs between the lines, and which lines are affected. The whole question of limb shifts can only be resolved in the context of considering outward flows, which should give rise to blue shift in the center of the disk, and in consideration of gravitational redshift, a general relativity, which should affect all areas of disk similarity. 5. Quasars intrinsic redshifts. 6. K effect correction to a cosmic object's magnitude or flux, the total energy crossing unit per unit time, i.e., and which I call time, I use the word nadal. So it's basically time as joules per square meter per second that enables measuring light at a redshift converter to equivalent measurement in the object's rest frame. Okay, now let's get to non-expansion velocity causes of redshift. Here's the gist of the whole thing that I'm doing today. The other explanations are tired light theory. This is the best candidate for redshift not being completely the result of the Doppler effect. This theory involves light experiencing losses due to absorption while traveling billions of kilometers, because it is impossible for anything to travel those vast distances without experiencing any losses. These losses may be sufficient to account for part of galactic redshift. In comparing the no evolution expanding universe model with the no evolution tired light model, 4 types of observational tests produced data that better conforms to a tired light hypothesis. Additionally, the latter do not require ad hoc assumptions concerning rapid galactic evolution. The simplest interpretation of results requires assuming significant evolutionary effects. Euclidean space, cosmologically static galaxies and photon energy loss of about 6% over 10 billion light years. This stepwise incremental energy reduction explains redshift quantization observations. In the BBT model, there is no acceptance of light losing any energy to the macrocosm as it is traveling vast distances. This is in clear violation of the second law of thermodynamics, SLT. Any device claiming to work while contravening SLT would never qualify for a patent. There is an obvious reason that photons do not lose energy in this voyage. They do not exist. However, light waves are real, with properties of diffraction, refraction, and frequency, and their loss of energy in being propagated through space is revealed by their redshifts as a function of distance. In expansion models, redshift quantization requires multiple assumptions, but this is not the case in the simpler tired light model. Additionally, this model has the advantage of conforming to observations of a slowly evolving stationary Euclidean universe with gradual photon energy loss over cosmological distances. In a 2016 paper, Louis Marmot discussed 20 physical redshift mechanisms not based on expansion velocity. If a mechanism can somehow cause light to lose energy, this will cause redshifts. But to agree with observations, it must not cause light scattering. Glenn Borchardt writes, quote, "It would be impossible for light to travel billions of light years without losses. The solution could be flowing," that's end of quote. "The solution could be flowing ether particles, which being far smaller than quantum entities do not scatter light, but would cause light to redshift as energy is lost from moving through it. Galactic redshift would be proportionate to distance." Now, a third cause, third alternative for redshift. It's known as redshift quantization, also known as preferred redshifts, redshift magnitude bands, redshift periodicity, and redshift discretization. So this hypothesis that redshifts of cosmologically distant objects, especially galaxies and quasars, cluster around multiples of a particular value. It is a concept that there is a tendency for quantized redshifts of cosmologically remote objects such as galaxies, which means being at multiples of a specific value. Due to the relationship between redshift and distance, redshift quantization either can result from galactic distance from us or can indicate that the redshift is not a suitable way to determine cosmological distances. The significance of either of these being true would be devastating for the BBT. It would destroy the Big Bang Theory. In inflationary models, the redshift is accounted for by the concept of expansion of the universe and is termed as cosmological redshift. Eliminating errors in analysis or measurement, quantized redshift of cosmological objects shows either that they exist as a quantized pattern around the Earth or that an undiscovered mechanism for redshift unrelated to cosmic expansion exists, which is referred to as non-cosmological redshift or intrinsic redshift. Scientists who oppose the Big Bang model use evidence of redshift quantization to support their position. Astronomer William G. Tift reported evidence of this pattern in 1973. Halton Arp, winner of the 1960 American Astronomical Society's Helen B. Warner Prize for Astronomy, subscribed to the redshift quantization theory as an explanation of the redshifts of galaxies. Arp maintained that redshift is only secondarily due to an object's velocity and primarily caused by its relative youth. In Arp's understanding, two components determine the value of the observed redshift. There is an inherent one determined by the object's matter, which changes over time. This is the largest factor in the total redshift of the quasar. The other component is the object's velocity. Arp produced some observational evidence to support redshift quantization. Using large telescopes, he made images of multiple quasar pairs. Inferred from their having extremely high redshift, Z values, they were supposedly receding very rapidly from us, which implies that they are very distant, ranging from 575 million to 13 billion light years. His photographs revealed that they are physically associated with galaxies that astronomers know are relatively close to us with low redshift values, which it's amazing. They shouldn't be that close. Arp's numerous images showed high redshift quasars balanced on two sides of their low redshift parent galaxies. These quasars are physically associated with low redshift galaxies, ones that we know are close to us. The vast number of these pictures makes it very improbable that the occurrence results from random location or an illusion, creating a seeming location that is incorrect. The significance of Arp's photographs is enormous. It falsifies the Big Bang Theory, BBT, by taking away the concept that cosmological redshift must be evidence of an expanding cosmos resulting from the Big Bang event. Talking more on, I covered the tired light theory. Yeah, I don't need to go to that one again. Okay. Another cause, ether as the cause of redshift. In The Physical Cause of Gravitation, 2018, Glenn Borchardt writes about ether deceleration theory, ADT, where ether density increases with nearness to matter, which is just the opposite of his earlier universal cycle theory. We see galactic redshift proportionate with how far light travels. For that portion of light's journey through ordinary matter areas, such as our galaxy and solar system, we observe far less redshift. Borchardt writes, quote, it's not a direct quote, but he explains that this is because matter interferes with the short range travel of ether particles, which resulted in the traditional conception of matter attracting matter. The formation of anything amounts to the accumulation of its various parts, and interference equates to a deceleration of ether particles and an acceleration of baryonic matter. Burckhardt contends that ether pressure, e.g., short-range activity of ether particles, increases distally and decreases proximally. Ethereal redshift is an inverse function of baryonic matter density because light velocity relates to ether density. This explains redshifting of light from massive objects, decreasingly affected by ordinary matter held by gravity. Pound and Repka showed blue shifting of EMR, electromagnetic radiation waves, coming toward Earth's surface, where less compacted ether affects the light, and redshifting for outward bound waves. Thus, ethereal redshift is the mislabeled gravitational redshift. Now, is there evidence for an expanding universe? Let's go through. There's something called the expansion test. When distance to a galaxy is more than several million light years, methods of measuring distance apart from the Hubble law are extremely problematic. At large redshifts, the redshift distance relationship, the large-scale extension of the Hubble law, is used so that redshift is a proxy for distance. Although the Hubble law applies as a method of determining distance, the mechanism for generating the redshifts is as yet unknown. It may provide a measure of cosmic distance to the source observed galaxies, but it is not the result of expansion. Now, the cosmic inflation concept and dark matter. Alan Guth, the originator of the inflationary theory, writes in the Inflationary Universe, quote, "Despite its name, the Big Bang theory is not really a theory of a bang at all. It is only a theory of the aftermath of a bang," end of quote. He points out that the BBT's equations depict the way the primordial fireball expanded and then cooled to form the structures of the universe without referring to what precipitated the bang or what banged, something that inflation attempts to explain. Inflationary cosmology is not a single theory, but a cosmological framework constructed on the concept of repulsive gravity causing expansion of space. According to Guth, inflation refers to a rapid cosmic expansion in which gravity was a powerful repulsive force, increasing the volume of the universe by at least a factor of 10 to the 78. That's 10 followed by 78 zeros. That's quite an increase. Expansion supposedly emerged from a realm that was, quote, wild, chaotic, energetic, end of quote. Inflationary cosmology asserts that the Big Bang occurred once the required conditions were present. These included having an inflation field for available energy and negative pressure needed for repulsive energy. The theory asserts that the already existing universe experienced an inflationary bang, which was not necessarily the creation event of the universe. That is an ambiguous and unclear idea, and it shows confused thinking. If the universe already existed, then the inflationary bang did not create it. However, the phrase, quote, not necessarily, end of quote, implies that it could also have been the creation event. Inflationary theorists hypothesize that the inflationary epoch started 10 to the negative 36 seconds after the Big Bang. I think I covered that, and ended at 10 to the negative 32 to 10 to the negative 36 seconds. Now, Guth proposes that a seed tinier than a proton, which included all mass energy that exists today, inflated to the size of a basketball within this incredible brief duration. More recent ideas on inflation suggest that the universe may have inflated to cosmological sizes. Guth does not explain what caused inflation to occur. During this rapid inflation, a smoothing out took place for any irregularities in matter's distribution and even in space's structure. It is hypothesized that at inflation's conclusion, the expansion energy transformed into mass, energy, and matter, which combined with the newly generated protons and electrons. Guth does not appear to understand that energy, which is a matter-motion calculation, And for those that have read Burckhardt, they'll understand what that means. But you have to read Burckhardt's definition of energy. So which is a matter motion calculation does not transform into matter. That is logically impossible. According to this theory, the diminishing of the repulsive gravity of inflation enabled the so-called attractive gravity to dominate, which resulted in the clustering of matter into galaxies and stars, etc. According to this theory, 7 billion years after the Big Bang, on a cosmic scale, the size of galactic structures, repulsive gravity once more became dominant for no explicable reason. Inflation theory proposes that because this additional dark matter lacked any electric charge, radiation could not make it smooth, enabling the dark matter to cluster together, causing irregularities in this expanding universe. When decoupling of radiation and matter occurred, dark matter was 10 to 100 times as common as regular matter. This inflation with the dark matter scenario supposedly accounts for the smooth CMB by the time of decoupling. CMB, once again, means cosmic microwave background. Since Guth first announced his inflation theory in January 1980, cosmologists still have not decided on what caused the hypothetical inflation. They only have speculations such as the strong nuclear force separating from the other elementary forces at the time, thereby producing a positive vacuum pressure or negative vacuum energy density. They further surmised the occurrence of a type of phase transition such as water becoming ice, which left the universe very unstable. According to BBT proponents, the vacuum pressure or energy resulted in a marked anti-gravitational effect that acted as a strongly repulsive force, stretching the boundaries of the universe from the size of a proton to that of a grapefruit. Previously, they had agreed with Guth that the boundaries had increased to basketball size. Now they say it is grapefruit size. And as mentioned, some inflation theorists think it may have been of cosmological size. There are two significant issues with this theory. First, based on a 500 million light years diameter of the universe at 380,000 years of age, this means that during inflation, the universe expanded faster than the speed of light. Because I use the concept that space is matter, I do not accept that this speed is possible. The inflation theorists argue that it is possible because they do not consider space as matter. On the one hand, BBT posits that space is a void that is inflating, thereby causing the galactic clusters to move apart. They do not offer a reasonable explanation of how a void can expand. They also claim that this void contains fields, in which case it is not actually a void, and they call them quantum fields. In the fabric of the cosmos, physicist Brian Greene writes that we have no idea of what conditions existed prior to inflation, and the probability for its occurrence is unknown. As Greene admits, the reason for believing in inflation theory is that it offers a solution to apparently separate problems: the origin of structure, low entropy of the early universe, flatness, and horizon. Dr. Paul Steinhardt, a cosmologist and theoretical physicist at Princeton University, co-authored the underpinning papers for the inflationary theory in the 1980s. Because it produces a multiverse creating infinite kinds of patches of space for any possible cosmological result, he is now one of its severest critics. These limitless patches are not homogeneous, isotropic, or flat, and lack nearly scale invariant perturbations. Steinhardt emphasizes that inflation is not a solution to the horizon problem. He comments that it is an improbable accident for the universe to have the isotropy and homogeneity which apparently occurs. Steinhardt points out that by producing the multiverse, the inflation hypothesis has so much flexibility that any number of observations cannot falsify it, and no observations since its creation support it because the theory accommodates any result equally. Considering that there is no possibility of disproving it, inflation theory does not qualify as science. Planck satellite observations from the year 2013 and 2015, along with previous ones from SPT, ACT, and WMAP, and other experiments, eliminate a wide spectrum of complex inflationary models in favor of single scalar field models. Significantly, every simple inflation model lost favor compared to ones with plateau-like potentials. Remaining models needed fine-tuned additional specifications combined with further unlikely beginning conditions than are required by the simplest models. Cosmologists refer to the situation as the unlikeliest problem. In their 2013 paper, Aegis, Steinhardt, and Loeb comment that until recent data from WMAP Act and Planck 2013, classic inflation's main problems were conceptual, multiverse unpredictability, quote, were conceptual, quote, multiverse unpredictability, end of quote. The quote, Louisville problem and the quote, entropy problem. They conclude that the data shows that even if inflation cosmologists find solutions for all conceptual problems, observations are disfavoring classic inflation. So here we get to this. Universe is not expanding. The expansion of the cosmos is the most basic hypothesis of BBT, but observational facts contradict this assertion, which necessitates constant add-ons and adjustments to this deeply flawed theory. For example, in 1917, Albert Einstein created the concept of the repulsive cosmological constant force to explain why the cosmos did not succumb to its own immense gravitational influence and contract. And he created that before they came up with the idea of an expanding universe. With the later discovery of galactic redshift, supposedly resulting from the stretching of galaxies away from us with expanding space, Einstein temporarily dropped his idea of the cosmological constant because now this surfaced as the reason that cosmic collapse does not happen. Later, the cosmological constant was revived and reinterpreted as, quote, vacuum energy, or, quote, energy density of space, end of quote. That occurs in quantum mechanics. Presently, it is closely associated with hypothesized dark energy. Whatever that, I have no idea what dark energy is. In 1922, mathematician, cosmologist Alexander Friedmann developed a solution to Einstein's field equations of general relativity. It required an expanding cosmos, which became the foundation of the BBT, although it also was a basis for steady-state descriptions. Using three different models, he explained how observations of an expanding cosmos would occur everywhere with an isotropic and homogeneous appearance. He did this for each of three different models. In an open universe, where the amount of universal expansion outstrips the escape velocity of all matter, space curves negatively and expansion never ends. A closed universe has positive curvature, with gravitation ultimately ending expansion and causing it to contract back to its size at the hypothesized Big Bang, contracting right down to something smaller than an atom, apparently. It is theoretically possible that in this model, the universe could have endlessly repeated expansions and contractions. And that's a model right now that Sir Roger Penrose is talking about. The flat universe model balances between open and closed as expansion continues endlessly until after infinite time, its velocity moves towards zero with no curvature in space. Apparently, Friedmann defines, quote, infinite time, end of quote, as an extremely long duration, but not one that continues forever. The present consensus of BBT uses this last model. Sufficient matter exists such that it will eventually halt expansion. BBT's basic premise that the cosmos is expanding is an assumption, not a fact confirmed by observation. There are four classical tests for expansion based on the assumption of redshift of galaxy light representing the velocity of the galaxy moving away from us. The tests concern relationships between galactic redshifts. It is indisputable that distance of ordinary galaxies correlates with their redshift, but we do not have any proof that shows that increased distances cause redshift. The first test is redshift for galaxies versus apparent magnitude. Closed universe expansion models appear to correspond with observations, which also fit with a static universe model that has no free parameters. Because static models are simpler theories, the test favors these based on the application of Occam's razor, because they do not require inventing unnecessary hypotheses and they have fewer free parameters. The second test examines redshift versus number of galaxies. Except in the case of an open universe and with the application of evolutionary corrections required at a redshift of 0.4, a period when galaxies were like today's, this test does not agree with expansion models. It supports static models, which do not require more parameters. Test number 3 compares galactic redshift with surface brightness. Attempting to correct for the Malmquist bias effect, which causes detection of a disproportionate number of intrinsically bright objects, presents the greatest challenge of any in this test, making it difficult to draw conclusions. This biased data agrees with both models, although they have higher correspondence with expansion. The fourth test of galactic and radio sources redshift versus angular size has the least observational bias of the 4 tests. Observation results of galactic cluster radii and independently from brightest number of clusters support static universe models while contradicting the predictions of all Friedman expanding universe models. Although results from the greatest angular sizes of double radio sources offer less support for static models, they have strong divergence with every expansion model. Absences of small radio sources in results provide cosmological parameters that are not consistent with expansion or static models. However, they could indicate interplanetary scintillation effects, which are momentary random fluctuations in celestial radio waves intensity, like a star's twinkling in the visible electromagnetic spectrum. Of these 4 tests, 3 of them support static universe models, with the 4th test not applicable to most static models. The only test that agrees with expansion has problems with observational bias. BBT proponents need to hypothesize strong evolutionary effects, including ones that are counterintuitive, such as the intrinsically smallest radio sources are the strongest ones. BBT requires that there be little or no deceleration of the universe or accelerated expansion. Big Bang theorists describe the cosmos as strongly open, which refers to a model in which expansion continues without end due to insufficient mass to balance it by gravitational influence. However, all observations from small radio sources imply a strongly closed universe, which is one with enough matter and therefore sufficient gravitational force to stop the expansion. For static models, we only need to assign significance to galaxy results in agreement, because redshift does not correlate to distance for radio signals, quasars, and other radio sources. 2 other tests are also available to test for expansion. One involves a test of supernova light curves. If expansion were occurring, then we would observe a stretching of these in high redshift galaxies resulting from the originating galaxy receding. This test yields ambiguous results. Another test uses galaxy evolution. If the Big Bang occurred 13.799 billion years ago, the appearance of galaxies is relatively recent, and their evolution would be a significant aspect of the young cosmos. In a non-expanding universe, present galaxies would be like those of 12 billion or 13 billion years ago. The radio galaxy 3C65 at a redshift of 1.2 would be larger and fainter than any present local galaxy. This necessitates evolutionary effects. However, because distance does not correlate to redshift for quasars and most radio galaxies in static models, it is obvious that we cannot make size and intrinsic brightness inferences for radio galaxies. Static models do not interpret a quasar's development to ordinary galaxies in the same way as the BBT, which rules out using quasars in any test. An additional test of expansion is the Tallman test, described in the next section. The Bucher-Oemler effect hypothesis is that a greater percentage of blue galaxies are in the cores of galaxy clusters than in the cores of low redshift clusters. Astronomers presume this to be evidence that galaxies are constantly evolving. There are many fainter blue galaxies at redshifts of 0.4 and higher up than appear to exist in our local area. However, it seems likely that these distant faint blue galaxies have a local counterpart in galaxies with low surface brightness, LSB. Years ago, astronomers had difficulty finding LSB galaxies, but presently they find them as frequently as spiral ones when constructing surveys specifically designed to locate them, although they are more blue shifted. The close resemblance between spiral galaxies and faint blue galaxies clearly invalidates the theory of galactic class evolution. Now here's more evidence for no expansion. We must keep in mind that the theory of cosmic expansion is just conjecture without any real evidence that non-BBT models cannot also explain. Okay, so I'm saying that there's evidence, but there's no evidence that non-BBT models can not also explain. Big Bang theorists invented this because they needed it to account for the universe's parameter. William Sumner has recently pointed out that introducing new space in expansion dilutes the vacuum's permittivity. This results in changes in the frequency around atoms, which has twice as much effect on observed redshifts as does the speed of expansion. When the equations include this, it indicates a contracting universe. This is something BBT would not be able to explain. BBT depends completely on interpreting galactic redshift of light as being principally the outcome of the Doppler effect. This redshift is proportional to distance, which astrophysicists infer from brightness. However, the only explanation for redshift those astronomers considered possible was the velocity of light source moving away from us. Therefore, their inevitable conclusion was that a galaxy moves faster as its distance from us increases. Without this connection, there would be absolutely no basis for an expanding universe or the extrapolated Big Bang. Until the concoction of the BBT, it was an axiom that conformed to common experience that as an object gets further away from us, its brightness per unit area, surface brightness, stays constant while it appears smaller and dimmer. However, BBT advocates claim that at galactic distances, an expanding cosmos must cause these more distant objects to look larger but fainter, and the light becomes dimmer from the stretching effects of expansion. Therefore, BBT supporters postulate that with increased distances, surface brightness decreases. This means that our strongest telescopes would not be able to detect the furthest galaxies, except for maybe the James the new one, James Webb Space Telescope. It may be able to, because according to so let me repeat that. This means that our strongest telescopes would not be able to detect the furthest galaxies because according to the BBT, they should have surface brightnesses dimmer by hundreds of times compared with the equivalent proximal galaxies. However, a study by astrophysicists Eric J. Lerner, Renato Falomo, and Richard Cardo Scarpa contradicts the BBT prediction that Euclidean geometry does not work at great distances. Their study, published in May 2nd, 2014 in the International Journal of Modern Physics, D, provides strong support for the concept of a non-expanding universe. And then I think I all covered this about on Earth, the solar system, and Milky Way objects get further from us as they appear fainter and smaller, while their brightness per unit area remains constant. In contrast, the Big Bang theory asserts that objects should appear fainter but bigger in the expanding universe as surface brightness decreases with the distance and the light is stretched. Thus, the surface brightness of the most distant galaxy should be 100 times dimmer than similar nearby galaxies, so that they would be undetectable with present-day telescopes, excluding the James Webb Space Telescope. When distance to a galaxy is more than several million light years, methods of measuring distance apart from the Hubble law are extremely problematic. At large redshifts, the redshift distance relationship, the large-scale extension of the Hubble law, is used, so that redshift is a proxy for distance. Although the Hubble law applies as a method of determining distance, the mechanism for generating the redshifts is as yet unknown. It may provide a measure of cosmic distance to the source observed galaxies, but it may not be the result of expansion. Picking about 1,000 of the most luminous spiral galaxies, they matched close and extremely far away ones for average luminosity and compared their size and brightness. Their observations showed identical surface brightness of galaxies irrespective of their distance. This result corresponds to expectations from Euclidean geometry in a non-expanding cosmos, thereby refuting the BBT expanding universe model, in which surface brightness diminishes with increased distance. The researchers applied the Tallman Test, devised in 1930 as a test to determine whether expansion was occurring, by using dimming of surface brightness as the criteria. After analyzing UV surface brightness of luminous disk galaxies from Galax and HUDF datasets, reaching from the local universe to Z5, they concluded that surface brightness stays constant, as would be expected in a static Euclidean universe. But contrary to predictions of the BBT, when scientists compared the brightness and size of about 1,000 nearby and extremely distant galaxies, using the most luminous spiral galaxies while matching average luminosity of far and near samples, they discovered identical surface brightnesses of distant and nearby galaxies. These results contradict the BBT prediction of a huge reduction of surface brightness, but agree with what would be expected from ordinary geometry in a non-expanding universe. And then Lerner commented, of course, you can hypothesize that galaxies were much smaller and thus had hundreds of times greater intrinsic surface brightness in the past. But just by coincidence, the Big Bang dimming exactly cancels the greater brightness at all distances to produce the illusion of a constant brightness. But that would be a very big coincidence. End of quote. There was another surprising result to their study. To apply the surface brightness test and match far and close galaxies, they first needed to determine each galaxy's actual luminosity by linking redshifts with distances. Extrapolating the well-substantiated observation that redshift remains proportional with distances in the nearby universe, they applied this to all distances. The scientists checked this relation between distance and data on redshift supernova brightness used in determining the supposed accelerated expansion of the universe. Dr. Renato Falomo of Italy's Osservatorio Astronomico di Padova commented, quote, "It is amazing that the predictions of this simple formula are as good as the predictions of the expanding universe theory, which include complex corrections for hypothetical dark matter and dark energy." Study co-author Dr. Ricardo Scarpa from the Instituto de Astrofísica de Canarias in Spain commented, "Again, you could take this to be merely coincidental, but it would be a second big coincidence." The researchers concluded that without expansion as a factor, redshift with greater distances must be resulting from something that happens to light on its journey here through space. Lerner stated, quote, We are not speculating now as to what could cause the redshift of light. However, such a redshift, which is not associated with expansion, could be observed with suitable spacecraft within our own solar system in the future. Conclusion. Is it possible that many scientists oppose the abundant and strong evidence regarding other causes of galactic redshift because they have linked their careers to the Big Bang model? And they fear the consequences that arise in being a dissident scientist? I think it is highly likely that this applies to most BBT cosmologists. Alternative explanations for galactic redshift, then BBT will lose many of its supporters. Is the evidence consistent with an expanding universe? Observations that rely on unprovable assumptions are either consistent with an expanding universe or disagree with the concept. But in response to all contradictions that arise, Big Bang proponents adjust the models so it can be in accord with any new evidence that is discovered. Evolution of galaxy size is used to counter those apparently contradictory lines of evidence. Regardless of whatever observations are made, an alternate explanation can always be submitted. To ensure that BBT remains unchallenged, alternative models are denied publication regardless of the quality of the research. Now here's some recent material from December 14th, 2021. In a study published, scientists propose that the Big Bang was not the beginning, but just a special moment in the evolution of this always existing universe. Physicist Bruno Bento and his team presented research demonstrating that the universe had no beginning. This work challenges the generally accepted theory that the universe was born in a Big Bang about 14 billion years ago. And as mentioned, this research came out December 14th, 2021. The objective of the study was to discover what the birth of the universe would have looked like without the Big Bang singularity. Contradictions. Studying this issue, they faced many contradictions that arise when comparing generally accepted theories. It is believed that the nature of the universe is most reliably described by quantum physics and general relativity. At the same time, quantum physics has successfully described 3 of the 4 fundamental forces of nature, but the 4th, gravity, from its position, does not fit into the framework. General relativity has no reliable results when studying the centers of black holes and the mechanism of the birth of the universe. Singularities. These controversial areas are called singularities, points in space-time where the laws of physics we know stop working. At the same time, calculations show that within both singularities, gravity becomes incredibly powerful, even on a tiny scale. And then they go into the theory of causal sets in their study. The researchers used the theory of causal sets, which is a type of research in quantum gravity based on a mathematical hypothesis about the discrete structure of space-time. This approach radically alters our concept of space and time, reimagining space-time as a series of discrete fragments or space-time atoms. This theory imposes strict restrictions on how close events can be located in space and time. According to the theory, they cannot be closer than the size of an atom. The authors assert that the theory of causal set eliminates the problem of the Big Bang singularity because singularities in this theory, matter cannot be compressed to less than the size of an atom of space-time. Thus, singularities are impossible. Classical view. The study's authors maintain that the Big Bang cannot be the beginning of the universe because the causal set is infinite, in contrast to the BBT, where the causal set emerged from nothing. Physicists concluded that the universe may not have had a beginning. Therefore, it has always existed. And what we perceive as the Big Bang could only be a special moment in the evolution of this always existing causal set, and not its true beginning. That's the end of my presentation. Hello? I can't hear you.
That's because I have myself on
There we
mute.
go.
So
That's
I was
the end, and
typing.
then I'm open for yeah, when I use the word space-time, I'm using it the way physicists are using it. I have
Of
to use that,
course.
even though to me it's a
Well,
non.
when for you, George, when you say space time, I assume that because that's
Yeah,
not a term that you
yeah, because
use
I don't
or
speak
believe that
time.
exists, right?
Yeah,
Space time is, I mean, even if you look at it linguistically, it's absurd. There's a couple of things just linguistically and logically are absurd, right? The universe started and ended. I mean, it doesn't make any sense. And
no,
also, multi universes, they're sort of the same thing.
yeah,
When you go across languages, one of my fields is linguistics. When you go across languages, most cultures have a word that means everything.
yeah.
Everything. There's not like there's not a word that means everything and then we turn it into seven net everythings.
You
It,
know,
it, the universe is everything. It can't be multiverses. It's everything. Everything's existent.
someone that you might want to reach. Go to his Facebook page, mathematician Fred Van Ostayen, and
Mm-hmm.
him and I have been talking about the words and languages, and I've been sending each messages and how difficult it is to communicate through words. You
Yes,
know,
it is. It
I
is.
was reading something yesterday where psychologists say that 95% of communication is nonverbal. I think it's like 99.99999% because each person has to have the same definition for a word for effective communication. And we all have varied definitions on any word you want to use. If
Yeah.
I say tree, what does that mean? You
Yeah.
don't know what
Yeah.
kind of tree I'm talking about.
Yeah. Well, what in linguistics we have a word for that. It's called an idiolect. An
Ah,
idiolect is the dialect of each person. When
right,
for instance, I had I said conjugation,
right,
that word, right? For it does. It's not conjugation. It's conjugation. I
right.
corrected that after I was 40 years old.
Oh,
But there are things. What we found in the brain, we can literally and have shown that there is one neuron for the concept of grandma, and actually it's other languages have the concept of grandma. When we have something that we all can identify and point to, even like a tree, we yes, there are variations, all that, but there are things the universe gives us, our perception and the things in the universe give us the ability to build a vocabulary. The
right.
problem is that we have taken vocabulary and we use it in the wrong ways.
There's the problem.
That's the problem. We
That's
don't When we use the word universe, it should mean everything. You can't have multiples, you
right.
can't have five of them. And not only that,
Absolutely,
yeah, and not only
absolutely.
that, the universe is something always here. Some people were talking about religion in the Big Bang. Well, I agree and disagree with that concept. Religion, oftentimes, the more organized religions will catch up to mainstream science. And so, at one point, for instance, the Catholic Church, I believe, caught up and said, okay, the Big Bang is real. It wasn't, some people say that's for the creation part. I don't think it's so much of that because you have in religion also, in, for instance, Christianity and other religions, of eternity, right? God is there and always has been. So if you have a universe that is starting and stopping, does that mean God is starting and stopping? Does they live outside?
Right.
I think we're absolutely right. The problem is science poetry.
Mhm.
We are always having people talk about it as if it's literature, it's fiction. And so the moment people are using words that we have a very clear definition, if you go to somebody on the street and you say, what does universe means? It means everything.
Right.
And then you go up to him and says, okay, well, you can have three universes. No, there's only one universe.
Right.
But yet, what happens is we have people speaking in science poetry constantly.
Glenn
So,
Gorsuch would love what you're saying. That's his point exactly.
yeah, exactly, yeah. And here's a question. I'm going to ask you some questions before we get into people talking here. I'm putting a lot of comments on the screen. I want to thank everybody.
I
First,
like
I do want to thank Michael. That's his pen name. He donated $100 to us right online here. So super chats. If you are in YouTube, you can donate to our organization literally through YouTube. And I want to really thank Michael. Michael, he says he's just a layman, but this is a show he likes to come to on Saturday mornings to get his brain tickled. So thank you
um,
so much.
David. I just like to comment on when you're talking about universe. the reason I created the word Notfinity Process and then matter in motion is to replace the. I just lost you. I see me, but I don't see you anymore.
That's because as you speak, I have you up
Oh, I
there
see.
like a
So
camera.
the word Notfinity Process, or the phrase matter in motion, is to replace, in a sense, the word universe, because I'm giving it the idea of like without end, everything that occurs and exists without end, and that's that phrase is trying to capture
Yes.
that.
Yeah, I mean, if you talk to, again, if you go a person on the street, the average person, probably in any country, you say, what is the universe? It means everything. Well, how long has it been around?
Occurs
Forever. It's
right.
like, well, I mean, the idea that it's in some sense existing, a corollary of that is the universe has to be everything, and it's always been there.
It has to be.
It has
you can't
to
have nothing. You can't have nothing. That makes no sense.
Yeah. So one of the questions I know people have, especially the lay people, because we've had upwards, well, we've been going around 50 people on all three platforms that we're going live to. So I want to thank everybody for tuning in. But one of the questions is, if the Big Bang isn't correct, what is?
That's actually, I'm going to hopefully get a question that you get into the infinite universe model of Glenn Borchardt. That's the alternative to the Big Bang. If you can prove the Big Bang, that means you've got this universe has no beginning, has no end. It just exists. And this is hard to wrap your mind around, like, because we're used to things having beginning and end in our normal lives, right? Something starts, something ends. So to conceive of, I don't think it's possible. Like, that's what I'm saying, Notfinity Process too. There's no beginning, there's no end, it just exists. It just occurs. And that's something that is extremely hard to, because of the way we're conditioned to think in terms of beginnings and ends. But because we aren't capable of conceiving of it, doesn't mean that that it's not valid. It's just that our brains are limited.
Yeah. But I think part of it too is our brains, our neural networks. Basically, they look at the world. If you show a neural network something over and over and over again, it's going to develop a pattern.
Absolutely.
People develop their idea of the way the universe works. People identify, they start putting that sort of this model in their head together. Most of the time, it's not too physical. And then they start, placing things in that model. So we have people in the green room. So if you're in the green room and would like to speak, you can wave. I know Dr. Ian Coyne, who's won some great awards with something. I don't remember. I don't know what it is, but I've seen that flashing through the chats here. I'll bring him up here. Whoops, I'm gonna go to this. There we go. Hey, hello. Ian, how are you?
Hello there. Hello, David. Hello, George.
Hi, Ian.
Yes, I didn't know if I should comment on that. I think somebody has awarded me a Nobel Prize or something.
Oh,
like that.
Congratulations! I mean, if you,
but I think you also qualify by
saying
the money comes with it later this year.
If the money comes with us, please make a donation.
Yes, right. So, I have a general comment and then perhaps a specific question, George. The general comment, again, I think actually Dr. Dennis Allen referred to this in one of the comments, that I've worked out a mechanism which basically is the same as a tired light mechanism, but it involves modeling the ether as a transmission line with infinitesimal capacitive, inductive, and resistive elements, and so on. And if you solve the differential equations and actually look at Maxwell's formulation, with a non-zero conductivity of the ether, you actually get a law, relating redshift to distance. It's a non-linear law, but it can, in certain small areas, be linearized, and hence you can get the sort of so-called Hubble law.
Right.
So that's just one thing, and I'm consistent with those ideas. But my question was this. Sometimes it's been posed to me. It's in regard to Holton Arp's showing perhaps that objects which were at different distances from us could evince the same redshift. Well, if that is so, isn't that a bit fatal for other theories of diminution of frequency with distance, such as the tired light, not only the Big Bang?
You're saying that would that refute the tired light?
Well, well, I think one of the aspects may be that he's only done it for certain areas, certain discrete
Yeah.
elements. But, you know, if you make a statement that, oh, look, here's an image of Holton-Arp's analysis, and he's showing this galaxy with this thing connected to it and so on, extraneous element, and they're both the same distance from us, according to various calculations, but they show different redshifts. Therefore, that disqualifies the common Hubble law and the Big Bang. But if you make that sort of argument, it could also be put back to you that it also negates the principle that there is a diminution of frequency with distance from us, such as via the tired light system.
Yeah, I understand. Yeah, it could. Yeah.
So how would you answer that? Would you say that Holton-Arp's analyses are just specific elements which show that it's not generally true, and you have to look?
It could be that. It could be just specific, and on the other hand, it might refute the tired light. It could be either.
Okay.
Yeah.
Well, that's
the reason we talked about both is because I don't know which one's right. I just gave like many possible explanations. I don't know which one is right. So
you know what? One of the things that has always bothered me, and I was totally shocked. I mean, I've had things that shocked me in a good way, and things that shocked me in a bad. This one shocked me in a bad way. When I read for the first time as a critical thinker that distance was in astronomy was gotten by colors.
Right.
I mean, it was just, you know, I'm thinking to myself, our ability to really know distances. I mean, we have to start there. I mean, we have to understand. We don't have like something we point a laser at it and say, this has got this distance. We are relying on a lot of basically rules of thumb, more or less. Isn't that correct?
Yeah.
And if it's the case that we're using rules of thumb to get distances in the galaxy in the first place, then what are we, you know, how can we stand, you know, and start really talking about, you know, the minutia of things when we are still using these kinds of rules of thumb, and we go on for, you know, I mean, we see things in Wikipedia. I know you've seen that, George, where the age of the universe has now gone from 13.877 to 13.7993.
Oh, they keep fluctuating it.
I mean, it's absurd. I mean,
you know what I'd like to mention right there, with this new space telescope, the James Webb Space Telescope, they're hoping to see the moment back in time to where the universe began. You know what they're going to find? Fully formed galaxies.
Yeah,
way at the, and then you know what they're going to do? How they're going to save the Big Bang Theory? They're going to say, oh, well, this doesn't discount or discredit the Big Bang Theory. It's just we now realize the Big Bang occurred 25 million years ago. Right. No matter how far out they look, they're going to find things. And they'll just, by the time I die, they'll be claiming the universe is 100 billion years old. I mean,
yeah, well, it started out in the early 20th century as millions of years, went to tens of millions, went to 500 million, and has gone up ever since. So
yeah, I mean, it just keeps. There's nothing the only thing that totally will just, I think, end it is when people accept that there is a better explanation for the redshift than cosmological expansion.
Well, one of the problems with
and that's the end. Then they don't need it.
I mean, one of the problems is somebody in the chat said, "Oh, the ultraviolet catastrophe. Oh, that was solved 100 years ago." Yeah, it was solved with an ad hoc. The person who said it, I'm going to use integers here. I have zero explanation for it, but it describes its empirical equations. The problem is until we start accepting, for instance, is it ether that lights this, or is it like the model of my father has? Those are two viable models for light. Until we accept that light isn't some, you know, magical thing that it go like Bork clearly points out that you can't have something traveling through the universe without something happening to it. But right. The reason we have that idea, I mean, if you ask the average person, when we send those probes out into space and it leaves the solar system, it's going to go at the same speed forever. right? It's never going to deviate. It's just
Yeah,
going
we're
to
just
keep
talking
going.
history to someone on that.
Right. And so the problem is that until we like in the ultraviolet catastrophe, the reason they can't get it because they have no model for light. If you use the particle model for light, we can explain it without having any ad hoc. If you have ether, you can say light is traveling through ether if that's what you think it is, and that you can explain the redshift in a different way. The problem is until light's a particle, light's a wave. It's a photon. It's so they use the word that's convenient at the time. For instance, they'll say photons are coming 10 billion light years away. Well, I thought it was a wave. It's the photon's a particle. So I think part of the problem is we continue to talk about things without a real model. And one of the things that people are asking here. Ian, did you have anything else or?
Well, just very briefly before I leave you, I'm just going to say that you were talking there about correcting perceptions, and George talked about the difficulty of that, and saving the existing paradigm. But the irony is that both in common parlance, the man in the street, and also in academia, they say that. The Hubble, I talked about the so-called Hubble's law a moment ago. They talk about the Hubble's law. It predicts this Doppler shift and so on, and that's what Hubble introduced in 1929. In actual fact, the truth is the opposite. Hubble looked at the redshift and he worked out the distances, and he wasn't the first to do it, but he catalogued these in detail, and he said we don't know what the explanation for this is. One explanation, which he didn't really accept, was the Doppler one. So the Hubble law is actually, as you know, relating redshift to distance, and it's only if you accept the Doppler shift as being the cause of that you get the velocity law. But that's commonly taught in academia, and it's believed by the man on the street, and it's put through by all the journalists, science journalists, that is what Hubble taught.
And what you're saying is so valid for so many areas in sciences. You have data, and then you interpret it according to your own assumptions. That often happens, and then the result is, oh, look, it supports what I'm saying. Yeah, I was talking to someone yesterday, one of my students that I'm working with, and I was saying, like in fields such as psychology or anything, you can do experiments, and then at the end of it, each school of model in psychology says it supports our theory. The same results. It's based on what your model is, and then how you interpret that data, and you can say the data conforms to your theory based on your assumptions and how you're interpreting it. And it applies everywhere. Physics, it's.
Well, yeah, but one of the biggest problems too is that you end up what you really have are systems. You don't have models. When the way again, it's language. To me, a model is a physical thing. This is a model.
Right.
Okay? A model isn't an equation. It's not like a non-fungible token.
Right.
I mean, it's you got to be able to pick it up. A model is something real, and the problem is we have systems. We have mathematical systems. Even our math screwed up. I mean, we have negative. There's no negative in the universe anywhere. So the problem is we have a mathematical system that doesn't fit. Mathematics is a superset of the physical world. And I have friends of mine saying that tensor equations for general relativity are physical. It's like, what? I mean, what we have is science poetry. Science poetry. People talk about it, and then when you ask them, what is charge? Oh, it's a positive and negative.
You talk about people in science talk about negative energy, negative mass,
dark matter.
The opposite of matter, the opposite of energy. I don't know what they're talking about with some of these phrases.
Yeah.
Negative. What's negative energy? Negative matter.
One of the questions we're getting here is about. I'm sorry, Ian. Did you have anything else?
Thank you, George and David.
Yeah, thank you.
We'll soldier on with these deliberations. Thank you very much.
I enjoyed their last talk in July too. Glad you called again.
But one of the things people are saying, well, wait a minute, mainstream explains the expanding universe with dark energy, dark matter, and a couple of things there, right? I mean, I have my own comment, but ideas. But go ahead, make a comment on that. Meaning, what do why are we looking at something else when we have perfectly explanations for? Well, that's debatable, but let's say they say that you have the Big Bang, expanding universe, dark energy, and dark matter.
One thing I'd bring up, I just saw a quote the other day from the physicist Richard Feynman, and he was saying in the quote, we should constantly be working at falsifying our theories, because he says that's the way science progresses. But the problem today is so many people are their careers and everything are based on Big Bang theory. Their training, and they've written books on it, and they don't want it to be disproven, because then they'll think, well, what have I spent the last 30, 40 years of my life on? But so I don't think it's good to be emotionally attached to any particular theory.
You can't.
And so if there's data that comes out, and as I highlighted in my book, Notfinity Process, 66 problems with the Big Bang, including, and then I say there's alternative theories, alternative models that don't have these contradictions and problems, then why can't we consider these? But you don't get any funding apparently for studies that are going to show alternative models. The only funding goes to Big Bang models. If you try getting a PhD on the infinite universe, on Borchart's infinite universe model, and you won't get an advisor.
No, they won't let you. It won't let you.
No, you want to get into your PhD candidature, you've got to have someone that's doing something. You're doing something within the box, within the confines of accepted theory. How does science progress, though, if no one's allowed to question things anymore?
Yeah, I mean, there was a T-shirt I saw that says, "I'd rather have questions that are unanswerable than not being able to answer questions."
The interesting thing is the one person, and I know you disagree with Einstein's relativity, and I show a lot of problems with it too. If he was alive today, he wouldn't be one of these people that say, "Oh, you mustn't question what I came up with." I think he would say, "Yeah, sure, question it." But yet the people now in science, he's become a god for people. The Big Bang theory has become a religion.
Well,
that's not science. You should be able to question things, saying, "Well, here's research." What happened to Halton Arp when he produced his photographs? Scientists refused to look at them because they said, "Well, if you've got images that show that the quasars are nearby, which that refutes Big Bang theory, well, we won't look at them because we know our theory is right, so your photographs must be wrong." What the heck? I dedicated my book to him because he was a brave man. They took his telescope time away. He was an award-winning astronomer. He had to go to Europe because he couldn't work at Palomar.
Yeah, our organization, I helped get our organization. I got some of the members over in Germany at the time to actually present him with an award because he was dying. And so we presented him with a Lifetime Achievement Award for what he did. Here's another thing.
By the way, he was familiar with Borchart's work. He liked.
Oh, yeah, I'm sure. Yeah. I'm sure he was. Yeah, and when there's a couple of things when you hear dark matter and dark energy. First of all, energy is a concept, so you can't have it. So if you're looking for energy anywhere, you're looking for a concept. There is no physicality to that ever. So you can throw that out, right? Yeah. But this dark matter problem. I see a lot of people who, when you go to something like dark matter comes from a phenomenon with the stars on the edge of the galaxy. We've had two people in our organization show that Newton's laws, gravitational laws, work fine because they treat everything as a sphere. And I've said this over and over and over. But what people do in the dissonant world is they have their theory. They say they want the mainstream to grasp it and accept it. So they go and try to say, "I know everybody's looking for dark matter, so it's ether," or "dark matter is electric," or "dark matter is this." To me, anytime you have any theory, I don't care if you really believe dark matter exists. Dark matter, dark energy exists because it's ad hoc. That's a fact. That's why they named it dark. It's basically that, I see this over and over and over,
You know,
again.
you follow the money. You know, these colliders like Hadron, $10 billion or something like that. There's 30,000 of these, huge amount of investment. And one of the things they're trying to do is create the conditions that were similar to the Big Bang, so they can create dark matter. Where the world is spending literally trillions of dollars. The 10 billion just on the Hadron Collider. I read there's 30,000 colliders. And one of the things, they're doing all kinds of experiments with particles. One of the things they're trying to do is, well, let's create dark matter because it's predicted by the Big Bang Theory. I heard a question. I heard that Glenn Burkhardt might be, has he called in? Is he
No, he's been here. He's been making comments. So.
No, but is he waiting to ask a question or anything?
No. I mean, he's been making comments, and I have been putting on the screen while you've been talking. Okay. Yeah. I mean, here's a person that I agree with completely. Dark matter, etc., is a band-aid for bad theory. Absolutely. and folks, again, I'm pointing to a lot of you dissidents. You guys are out there saying, I can explain dark matter. No, you don't need dark matter. In fact, if you look at the more modern theories or modern models out there, dark matter is not needed. So it's just got to be careful. People, what it is, it's an emotional need to be accepted. So you try to, usurp or incorporate things that mainstream can't explain, even if it's wrong. Even if it's a band-aid for a bad theory, people in the dissident world will say, I can explain dark matter because it's electric, or I can explain it because it's this theory or that theory. Careful, folks.
Could I just if you've got about 2 minutes, I was hoping I'd get a question, and I've got something. Can I just add something to the presentation?
Yeah, absolutely. Go ahead.
Here's a question that I was hoping I'd get. How did the cosmological expansion concept come about? And could the Big Bang Theory survive if redshift is shown to be caused by any of the phenomenon discussed?
Oh, that's a good question. Absolutely.
Yeah. So what I put on that was in 1927, Georges Lemaitre, an astronomer, theoretical physicist, and Belgian priest, created the Big Bang Theory of the universe's origin, which contended that the universe was expanding. This idea was ostensibly to account for observed redshifts of spiral galaxies, which were referred to as spiral nebulae at the time. Accepting that the universe was expanding and then looking at the process in reverse gave support to his concept that it began as the infinitesimal object. However, Lemaitre had another motive for his theory. Hans Alfvén, recipient of the 1970 Nobel Prize in Physics, stated that Lemaitre revealed to him that the BBT was designed to reconcile science with St. Thomas Aquinas' religious dictum of creation out of nothing, or creatio ex nihilo, hypothesis of the primeval atom or the cosmic egg, which was later named the Big Bang Theory. Lemaitre calculated the Hubble law. He based his theory on the work of Einstein and de Sitter, and he independently derived Friedmann's equations for an expanding universe. The redshifts varied in such a way that they led to his conclusion that there was a definite relationship between nebulae distance from us and their distance from observers. In 1929, Hubble provided an observational foundation for Lemaitre's theory. Hubble's experimental observations appeared to show that galaxies are receding in every direction relative to us at velocities directly proportional to their distance from the Earth and each other. In 1929, Hubble and Milton Humason devised the empirical redshift distance law of galaxies, which is now called Hubble's law. Using this law, once the redshift is interpreted as a measure of recession speed, it agrees with the solutions of Einstein's general relativity equations for an isotropic, homogeneous, and expanding space. The most important word here is interpreted. Because the expansion was isotropic, this appeared to be evidence that space was expanding rather than that the cosmic bodies were moving further out into a pre-existing emptiness. This interpretation led to the idea of the expanding universe. Hubble believed he had found that most of the objects in the universe were moving away from all other objects while the universe expanded. This led him to conclude that everything was once closer together originally when the universe began from a single point a few millimeters across, before exploding outward, and was so hot it consisted of only raw energy for hundreds of thousands of years before any matter could form. So to answer the second half of that question, Because redshift is interpreted as incontrovertible evidence of cosmological expansion upon which the Big Bang model depends, if phenomena other than expansion can be shown to be a better account of redshift, then the entire foundation of the Big Bang theory, which is cosmological expansion, evaporates and the BBT ceases to be supportable. At that point, the long-standing practice of generating new ad hocs for the BBT will also end, as there will be no way to save it. The only alternative model will be one that does not propose a beginning, such as the infinite universe model as described in Glenn Borchart's 2017 book, Infinite Universe Theory, and in my own book, Notfinity Process, Matter in Motion. So that's, I was hoping I'd get a chance to, there.
Oh, no. If you have any other questions you actually want to answer, that's absolutely too.
I had a question on that, so I had something ready to go.
No problem.
I've been seeing great comments coming through at the bottom of the page here. It's good to see that.
Yeah, I mean, one of the people are asking, I did a video on explaining the edge galaxy problem using Newton. Actually, there are 2 papers on that from our group. That a seminal one is by Cameron Rigbasol, who actually broke down the galaxies into their subcomponents and arms, and it turns out that Newton's laws of gravity completely describe the speed of the edge galaxies, because we continually make a galaxy's mass is put it as a point in the middle and a sphere. A galaxy's mass is not spherical. If you send a probe through a galaxy, it's not going to go and act as if it was being attracted by a sphere. It's going to be very different. It's like saying the Earth and the Moon have a spherical galaxy when you put them together. I mean, spherical gravitational field. Ask a NASA science or SpaceX scientist about that and see what they'll say about it. So the whole thing is people look at that. The problem is that answer is too simple, like a lot of things with the Big Bang. When people ask if the Big Bang is wrong, I said, no, the universe has been here. It's like a big soup. It's always moving. It's always changing. It's always, it's something that is it's much easier to understand than a Big Bang, because the Big Bang, you've got too many problems.
The interesting thing, which is hard to conceive though, if there's no end, no boundary to the universe, then it's not an object. Because objects are things like this is an object. This is an object, right? They have boundaries. So if the universe is, and only objects exist, if the universe has no limits, you can't really describe it as an object. That's the other reason I came up with the word Notfinity Process, because it's interesting that you can't.
Yeah,
it's not an object because it's got no boundary.
Somebody said somewhere, and I don't know who it was. I don't know. One of my friends, I think, he said, the ultimate, and we're talking about our particle model. He says, the universe is where all the particles are. That's what it is. It's where all the mass is. I mean, that's pretty much it. You can't. It's not something. It's absolutely not something.
There's no end to it.
Yeah, and I have also thought myself, no matter what model you believe is true, a physical model. So if you have some physical model, if you had an edge of the universe, what happens at the edge? Things like fall apart. Because if you believe in infinity, the things that keep things together is everything below it and above it.
Yeah.
As soon as you get rid of stuff there's really nothing, it falls apart. It's going to go into nothing. So.
Yeah.
Okay, I have a few more people I know here in the green room, at least 3 more people. Anybody want to come up and speak? I don't know. We have, I see James Keene, Cornelius, my father is there. Let's see, here I have some, yes, you had mentioned a couple times the word static universe.
Yeah.
Are you just using that in a mainstream sense?
Well, yeah, I know there's a history of the static universe, but I'm just using it when I'm giving these when I was referring to that, they're just comparing the static model to a expanding and showing that the static model actually it 3 times out of 4 accounted for things that the other one didn't. But and nobody uses the term static model. It's an old term.
Okay, yeah, that's what I figured. Okay.
Yeah, no.
So, what would you call it? I mean, what you call it, dynamic?
Yeah, I like that word, dynamic. Yeah, dynamic. Yeah.
Okay.
Yeah.
Again, if you have any questions directly or comments, you can just put a question or comment on the chat. and we have a few more minutes left, about 6 minutes left. Let's see, we have some Glenn's comments here.
Yeah, I saw some of his. He's had some good comments on the bottom of him.
Yeah, I'll put some up there for
Here's
people
what
to
causes
read.
accelerated called gravitation. Yeah, that's good. Where you're talking about what causes. I've got that in my book. The ether deceleration theory, the physical cause of gravitation.
Yeah. There's probably about 5 modern models for it. Some show that, I think 2 models that I know of show that gravitation is at the atomic level. It's not out, it's more of an atomic level. You've got even one person saying that everything is growing and it's pushing up against us, that gravity is that. And you have, there's the gravitonic model, and we also have the ether models have at least 2 or 3 that I know of that try to describe gravity.
There's Duncan Shaw's flowing ether model, which
no, it's the Vancouver ether model. That's what I call it. The reason I call it the Vancouver ether model because he was inspired by the fog or the
I see all the
come
fog
in and come out. No, that's what he said. So I call it the Vancouver model.
Yeah,
so
yeah,
I get credit for naming his model. So.
Yeah.
There's a person making a comment: continuous creation. The universe is being created and destroyed in each sentence, each instant. Well, it's not the universe, but things in the universe are being created, and it's not really being created and destroyed. It's being blown apart and put together. I guess that's another thing is people. I think that's Glenn Borker is a good question where people talk about are things always getting more complex, or do we have really things blowing apart and coming together that are simplifying and becoming more complex, or is even that a question, right? So alrighty. So I think we're coming up to the end here. We've got about 3 minutes left. People are discussing, I think, most of the questions. It says, and then what do you predict is going to happen with the Webb? Is it the Webb telescope?
Yeah, the James Webb Space Telescope. They've got it in position now 1.5 million kilometers from us in the so-called sweet spot where it doesn't need much fuel to maintain that spot because it's distance. As I say, when they get pictures back from the supposed 14 billion year beginning of, they're still going to see galaxies. And I had that question, I think, from Tallman in one of our communications. And
right.
I said to him, yeah, they're still going to see fully formed, mature galaxies. And that's my prediction. They're not going to see the beginning moment of the universe.
The first time I got involved with this group was 1996 at the it was the 3rd annual conference of the NPA, which was now this
former
organization.
NPA,
and it was held at Flagstaff, Arizona, which was great because they have an observatory, Lowell Observatory there. So I went there, and it was only a few years after what they called the first deep space photo, where they showed a photo. It was in the was in an auditorium they had at the Lowell Observatory. And I was standing there by myself, and I saw one picture, which was the night sky with a powerful telescope on Earth, which was a completely black void. And then they had the Hubble, which was about the time the Hubble was going up there.
There's the ultra deep field.
There it is. And that was on the wall at the time, which was only a year or two after I think it happened, not too long after that. And of course, what did they see? They saw lots of mature galaxies.
And this is like supposedly like as the universe was 13 billion, the ultra deep field. They're shocked with what are galaxies?
Yeah, basically what I really think is that the scientists say, what right do you have to tell me that the universe isn't 13 billion? What right do you have to have galaxies that look mature way beyond their years so far away?
Right.
They almost get mad at the universe.
I know.
So. Okay, well, thank you very much.
There's the book. I hope people buy it. It's, it's now available in hardcover.
Yes, it is.
There is, and you've got a comment on the back of it. You want me to read the comment that you put?
Yeah, sure.
From David, George is one of the 2 greatest living philosophers. I don't know about that, of our generation. And what Borchardt is to infinity, Coyne is to notfinity. he is capable of spanning all of physics, cosmology, and consciousness in one book. So that's very generous of you.
Well, the truth is that's the truth the way I see it. I mean, if I look at philosophers, we don't have a whole lot of what people I would consider to be philosophers in our group, and I honestly think that. So, I don't write it because I believe me. No offense, I wouldn't write it if I didn't believe it. So
No,
lucky you.
Yeah, it's great, great. I have a lot. Glenn Borchardt wrote on the back, and I'm gonna have to put Tao Lin's. Tao Lin reviewed my book and gave it a 5 stars on.
Yeah,
on
go to it. You can go to it.
On one of the books of the that he liked in 2021, which had this fantastic and he's going to be on your show coming up. I got to watch that.
Yeah, absolutely. Okay, thank you so much, George. I always enjoy talking with you today. Okay, you take care now.
Thanks a lot. Nice to see you, David.
All right, bye. Well, I'll tell you, that's just always a great time. I want to thank everybody who has come today. It was quite a good crowd. A live crowd across the 3 platforms of YouTube and Facebook. I want to thank especially those people who put in their super chats, who actually donated money. All the monies go to this organization, which, like I said, is about $2,300 a year for us to keep this going, both in our websites and in this programming, because we pay even for this kind of service. But without you, we wouldn't have these programs to talk with people like George Coyne today. If you haven't gotten his book, Notfinity Process, Matter in Motion, you got to get it. It really is fantastic. Glenn Borchardt, it's another work that's built on Glenn Borchardt's infinite universe theory. Our book, our model is also based on Glenn Borchardt's work. So, thank him for stopping by today and everybody else. So we're going to be taking this out and on our way soon here. And remember, stay critical, stay thinking. I'm Dave de Hilster, your science therapist, trying to get you to the promised land to become a critical thinker and not be married to even your own theory. I mean, as my dad says, hey, we're lucky to cobble together a few ideas and be just less wrong than the people before us. That's the truth. Don't fall in love with anything. Always stay critical. Ciao for now.